Welcome to our presentation on how to deploy your shiny new Lagom services to ConductR. ConductR orchestrates processes across machines from few to many. ConductR's goal is to be to operations what Lagom and Play are to developers. It is all about operational productivity. I'm going to show you how to take the Chirper demo and then deploy its 3 services and 1 Play application, along with an instance of Cassandra. We'll be deploying to what we call the ConductR Sandbox. The Sandbox allows you to test out your services before deploying to a ConductR production cluster. The Sandbox contains pretty much all that a regular production environment contains. Okay, let's get started. Firstly, let's ensure that our ConductR environment is in place. If you've not done so already, then you'll want to follow ConductR's Getting Started page. Let's look at that briefly. This page explains how to obtain Docker, Python, and ConductR's CLI in order to get started. It also tells you the latest release of ConductR, as you can see here. Version numbers for using from within SBT and from the CLI are provided. Let's now set up Docker's environment so that we can access ConductR's Sandbox. And now launch our SBT console, which is where we will build our Lagom-based project. Let's have a look at our Lagom sub-projects. When deploying things, we're only concerned with the impl projects, the implementations. You'll see that we have an activity stream impl, chirp impl, friend impl, and front end. You can ignore the other projects for the purposes of this video. Let's look at the project from within my IDE and what additional changes need to be made to accommodate ConductR. We have added 2 plugins to our development environment. The first, SBT Lagom Bundle, will introspect our Lagom projects and generate the packaging information that ConductR requires. The other, SBT ConductR Sandbox, isn't strictly necessary, but when included, it will allow us to run the ConductR Sandbox without having to leave SBT. Let's now look at the build file. Front end is a Play application. To enable Play for ConductR, we add a library named Lagom 10 ConductR Bundle Lib. We must also describe what resources are required and how it presents itself to the outside world at ConductR's proxy. Finally, we tell the Play application to bind to an IP and port that ConductR will allocate so that it doesn't clash with other processes. Note that we only need these settings for the Play application. Lagom services are automatically configured by SBT Lagom Bundle. With these settings, we're ready to package some bundles. Let's do that now. This command will apply itself to each implementation project and produce a bundle. A bundle is a package format required for ConductR and contains metadata in relation to your applications and services. One important aspect of bundles is their fingerprinted name. This fingerprint is a hash of the contents of the bundle. Therefore, if your bundle's contents change, then so does its name. ConductR also validates the hash when the bundle is loaded, and only bundles with hash compliant with that stated in the file name will be accepted. What this means for you is that you can have a unique reference back to a bundle that you knew performed in a certain way. Therefore, if you need to roll forward or backward, you can do so with confidence. Play applications require us to declare an application secret for its built-in encryption technology, as well as other things. We can supply different secrets depending on whether we are running in development, test, production, and so forth. ConductR allows us to provide configurations at the point we load a bundle. The minimal configuration declares a file named runtimeconfig.sh, which is a shell script. As declares an application secret but you can provide other environment variables for your application or service. You could even mutate YAML files and, well, anything you really need to do. You can easily maintain alternate configuration files for different target environments. Let's generate the configuration from within SBT. The configuration:dist command is used to do this. We don't recommend that you retain non-development style configurations in your project. You would generally have a folder on disk with the runtime config.sh file and then use a command we supply named shazar to produce a configuration for it. The nice thing about configurations is that they are also fingerprinted with the hash of the configuration's contents. When loaded with a bundle, ConductR will return a unique identifier of both the bundle and its configuration. This provides further surety that what you're loading is what you think you are loading. To recap so far, we've created bundles for our Lagom-based services and our Play app. We've also created a bundle configuration for the Play app. This bundle declares runtime-specific configurations such as Play's application secret. Let's now start up the Sandbox. The first thing to note is that you are prompted for an image version. We were provided with that version earlier when visiting the ConductR developer page. Let's declare it within our SBT session. We now start the Sandbox. We'll do so declaring that we want to enable visualization and 2 machines. ConductR is now starting up. Note, we're only starting 2 nodes. While you can run many services within the Sandbox, you'll quickly hit memory issues. That's because there is a difference when running services as JVM threads within development mode versus processes in a ConductR environment. Each Lagom service is configured with a ceiling of 128 megabytes by default, but Cassandra and Elasticsearch, the latter being used for consolidated logging when enabled, will each consume 1 gigabyte. Therefore, treat the Sandbox as a means to integration test your services and validate their configurations, but not necessarily as a place where you can stand up your entire system. That is, unless you configure the Sandbox's machine with enough memory, of course. Things should have started up. Let's take a look. Things have indeed started up, so let's see that more visually. Now it is time to add the bundles. What we're doing here is changing the current project to one of the sub-projects and then loading the sub-project's bundle into ConductR. Note that pressing Tab after load will pick up the last bundle that was generated for the project. Let's have a look at the remaining projects. Now let's load each project individually. Remember that the front end had some configuration. We can easily pick that up by tabbing it again after the bundle. There's one more bundle that we need, and that is for Cassandra itself. ConductR will resolve this bundle from a repository that we provide on Bintray. Before we load Cassandra though, we must configure it. We can generate some default configuration from within SBT by navigating to the root project and typing the following. What we've just done is load Cassandra along with some configuration for our Lagom-based projects so that they are able to discover Cassandra at runtime. We also run it as well as loading it. Note that given enough resources, then we could use a -- scale option to size the Cassandra cluster. Managing and scaling Cassandra on ConductR is straightforward. Let's look again at our cluster. We should now start our services. We should now be good. Let's test Chirper out. Requests to Chirper and the other Lagom-based services are routed either via the proxy from the browser or via the service locator within the cluster. The service locator is also designed to return the service that is nearest to the calling service in an effort to minimize any network latency between their interactions. Chirper is now using ConductR's service locator. Each of its services can be scaled. One last thing to show you, and there's a lot more to ConductR than what we've been able to cover here today. It also has a CLI for non-development style scenarios, for example when performing an operational role. Let's exit the SBT console and type a CLI-based command. Everything we did within the SBT console is available within the CLI. The options and arguments to the commands are the same. That's all for today. Thanks for watching and be sure to visit ConductR's documentation page for more information on operational topics.